I'm just testing a water effect I made. The water dynamics itself is actually based on a paper by Michael Hoffman. I'll leave a link in the description. The crepuscular rays in the background, that's actually based on work by Charles Humphrey. Also, I'll leave a link. The water itself is something I came up with, sort of caustic effects and the shining around the edges and all that. Instead of drawing the water target offset with a light and dark value, I actually do the highlights and the darkening of the edges of the water drops and stuff in the actual pixel shader. So all it does is it takes a copy of the entire rendered scene that would be reflected in the water. It's sampling an inverted version of it, and then it's distorting it with a sine and cosine value. And if you watch it, like if you watch this part right here, you can see that it's distorting it a bit too based on perspective. It's sort of a cheap perspective distortion though. It's just using the X value to distort it. So this is the regular texture that's passed in. That's basically the texture that's drawn, which is your water target, which is created here. Then this is my ray target. And then I mix everything together. I do an additive blend of the rays into the scene. And this is all done onto what I call full scene 1. And that is actually going to be your reflection texture. Any part that's not water is not reflected, it's just drawn as a normal pixel from this scene that's rendered here. If we go into the effect. So yeah, this actually is what's being drawn, and this is what's being reflected, which is the whole scene that's been rendered so far. Anything else will be rendered over top of this. Anything that won't be reflected. And this is my caustic texture. You could mirror this. I'm using wrapping because I think the wrapped version looks better than the mirror version. Angle's just a value that's just going to keep changing. This is the horizontal scroll value. If you're using a tile-based system, you might do this a little bit differently. Rather than saying H-scroll, you might have a different way of associating sections of water with tile or with regions in the world coordinate system. So as always, make sure that you're matching your pixel shader SV position color 0, text chord 0 to your vertex shader that you're using. I actually draw my quads using something I made in my own kind of sprite batcher. So when I draw my colored quads, I'm just doing this. It's adding in those vertices, and then when it's done, it goes to end, which sets the render states that were set up in the beginning, and just draws the triangles. It's important to do these in the correct order, because if you don't, it might not work right. Just before you draw your primitives, you set your texture. Right here, it's the same with sprite batch. If you send in the begin a pixel shader, but you don't specify a vertex shader, it won't matter. It'll just use the vertex shader that was originally being used, and then it'll use the new pixel shader in place of the pixel shader that your standard pixel shader. So instead of using this for the pixel shader, it'll just use this instead. This is what actually controls the water dynamics. You initiate a splash. This is kind of tricky to explain. There is a tutorial though, you can check the link in the description. It'll kind of tell you how this stuff works. I kind of combined some stuff, so this looks a little crazier than what's in the paper. This is where you update the water, and it uses Hooke's law to sort of spring these columns. Your target height versus your current height multiplied by a tension multiplier. That's how elastic it's going to be. And then you subtract from that speed value, the previous speed times your damping value. So that slows down the velocity, and this tension is going to boost your velocity. And then you add that to the current height, so the height will actually change based on that speed. This splash thing is actually where it creates the particles. I'm using velocity y divided by 4 to determine how many particles it created. It was originally speed divided by 8. I went divided by 4, so it would increase the number of particles If you went divided by 2, it would be even more particles. If you didn't divide it at all, it would probably be a lot of particles. Like if I went like this. Yeah, there's all kinds of splash now. Maybe I'll go divide by 2. So it's creating a certain number of particles based on how much velocity the rock has when it hits. The x value is factored into the direction that the particles move. I just added that in over here. The y value I'm not really factoring, but if the y value is negative, if the character is jumping out of the water, I might actually put some logic in here to add the y factor, like the upward velocity of the character, into these particles that are created so that they kind of shoot out of the water a little more as the character jumps out of the water. And this adjusts the springs or the columns based on the columns around themselves. It uses the difference to adjust, and this updates your particles based on gravity and velocity of the particle. Now, I was using this to remove particles before that are out of bounds, and I changed it to this because someone pointed out to me that this is a bit faster. I'm not sure if that's actually true, but that's what I'm using right now. We're using an alpha test thing here. This alpha test effect with the metaball target that we've created so that we can create the water particles. If you check the link in the description, there's an explanation of how that works. I'm scaling it by 2.3. You could modify that based on how big you want your particles. And I am still using orientation, even though it doesn't really make much difference. I am rotating them. After we do this additive blend of these particles into this metaball target scene, we render those, or that target, with the alpha test into the particle target. And we're using a reference value of 175. That kind of has a metaball type of effect, which kind of blends the particles together, or it kind of blobs them together. And this is where we draw in that particle target into the scene, into the final draw to the water scene, which is its own target in game 1. So we got this. So I'm setting the render target to water target and drawing the final water draw, which includes the final particles. And I'm using these colors here to blend between light blue and midnight blue as it goes down the particles. The red value in these is actually used to tell the shader how deep into the water it is. Same here. So this actually draws the quads that make up the columns. And the red value goes from 0 to 0.5. And what it does in the water shader is it uses that to catch the distance, which is in part used to determine the horizontal distortion, as well as how to blend the colors as it gets deeper into the water. And I changed the red value back to 0 because I don't really want it to look purple as it gets deeper. I'm just using the red value to communicate distance into water. And this is how you mirror your UV coordinate to extract the mirrored reflection from this reflection sample, which is your whole scene rendered so far. I'm using sine and cos to distort it. My perspective distortion is based on the center of the screen and the distance into the water, which is 1 minus distance. I'm adding 0.5 here because it's got to be centered. I'm using the original color from the water itself, that to sort of tint the scene. I'm using the color from the reflected image, which is distorted. So I distort the UV coordinates. I also get the color based on the UV coordinates that are not flipped, so the non-reflected UV coordinates, to get what's behind the water. And I distort it slightly less, so I divide it by 2 so it won't distort as much. And then I blend these colors together. The reason why I divide the gradient color from the original water scene by 2 is I don't want it to impact the color as much. So like if I didn't divide this by 2 and say I average them, and I divide this by 3 to get an average of the 3 colors. Oh, by the way, the third color, this is the color I'm getting from behind everything with some slight distortion. Color 1 is the original gradient, it's the original water sample. Color 2 is the reflected image color. I'm averaging them together. So That actually looks pretty good. Except I personally would prefer the water to be a little bit more transparent. So to make it more transparent, I just reduce the effect of the water image and divide by 2.5 so that you get a rough average here. A little more transparent, so I kind of like that better. So the reason why I'm adding uv.x and uv.y here is that as it passes through those coordinates, it's increasing the angle for each pixel. So the distortion will change as it goes through the pixels. You can experiment with these multiplication values, like this would determine how much effect that coordinate has on the sort of the frequency of the sine wave, and sort of gives you the frequency of the cos wave. And then this is your percentage multiplier of how much effect you want it to have. I could make it distort more horizontally if I wanted to. I could increase the frequency. I could do something crazy like that. And that looks absolutely insane. So yeah, I wouldn't do it that way. But let's say I did this. You could make some really funky effects here by experimenting with these values. So if you want, you can play around with those and see what kind of effects you can get. This is the caustics part, where we modify the final color again with this caustics effect that I made. So what I did was I made this wrappable caustics texture by offsetting it here, 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 and here, and then blending it all together and then using the smudge tool. And that way you get a seamless wrappable texture. And what it does is in the shader itself, it actually additive blends it in. But I didn't want the additive effect to be too strong. Oh, and it offsets it too by H scroll. That's the horizontal scrolling. And it uses the angle that we're passing in right here to update this offset value. I divide it by 90 because I don't want to offset very fast. Just nice and slow. Then we get from our caustic image the color that we want to additively blend in. So we don't average it, we just add it to the original color. And I'm reducing it based on distance. So based on how deep it is in the water, it'll have less blending effect. As it gets close to the surface, it'll be brighter. So that's how you get the UV coordinates for that. We sample the UV coordinates here, and then we flip it backwards and upside down, and then we sample it again. So we're kind of like, almost like making a mirror copy of it, getting the sample, the mirrored copy sort of, and then adding that in. So we're additive blending both of these color values into the final color. And that's what gives you this really nice caustic effect, which was made from this thing. If the alpha color is really small, it's basically see-through. What I have it do is I have it check the pixel to the right and the pixel to the left. So if the pixel to the left of the current pixel isn't see-through, if it's something that would be visible in here, if it's actual water, then we're gonna do some rim lighting on the edge of it, just on the right side of it, by adding these values to the color value that we just sampled from the scene. And we do the same thing for shadowing, except we check on the opposite side. We check if to the right of it there's something, then where we are right now, we're going to darken it. And that's what creates that sort of 3D look to the water droplets and the particles. If you were to pause this, you'd see the waves too, that on the left side of the wave it's a tiny bit darker, on the right side of the wave it's a tiny bit brighter, because I have light coming from the right. And it doesn't have to be light source accurate to be convincing, but you could make it light source relative if you wanted. So yeah, this is just for pixels that are along the edges of the waters. Oh yeah, I'm using Pixel Shader 3 here because I'm using cross-platform. If you go to File, Projects, New Project, and you C#, I'm using cross-platform desktop project, and that's why I'm using PS3, because that is the one that you would use with that, because that's your OpenGL pixel shaders. So it'll actually translate this HLSL essentially, or effects file, into a GLSL before it produces the final shader object. So you'll notice the water particles will actually move in the direction that the character hits the water, so depending on how high and how fast the character hits the water, like if it's straight here there'd be no splash, but a little higher and you get the splash. You can change the threshold too, so that you'll get a splash at a lower height or lower velocity. This is your velocity threshold that controls whether you're going to see a splash or not. The horizontal scrolling controls the sampling for the caustic and the mirrored caustic a little bit differently. So it kind of gives it more of a 3D scrolling look to the water. Right now I don't have the water particles updating for world to take into account the world coordinates, but if you were to add this to a game, all of this stuff would be moving relative to world coordinates. The way it would be doing it is it would, over here, it would simply be drawing this at a different position. So rather than using screen rect, it would probably pass in segments at actual positions. But there are other ways that you could do this too. You might not want multiple instances of water. You might do this a bit differently depending, but I'll let you figure that out. You could potentially also use a texture map or an animated texture map or a series of animated texture maps to create specular effects under the water too. Customized specular effects. That might be something you might want to add. Some surface sparkle. Although it kind of looks fine without the surface sparkle, because the animated caustic effect is kind of almost giving it a sparkle to the surface. In the original paper, there's this gradient thing here. I actually took it out only because I couldn't really tell the difference without it. So, I think this looks fine. But yeah, the point of it was to make it so that the metaballs would sort of fuse with the water surface. I didn't feel it was necessary, so that's the only reason I didn't include it, because it looks fine the way it is.